In this series of lessons, we will cover a dynamic routing protocol called Open Shortest Path First, or OSPF. We'll start by discussing some of the benefits of dynamic routing protocols in general and take an initial look at the OSPF routing protocol in particular. Let's start by considering this network topology. There are 4 routers. Each router is connected to one switch, and there is a computer connected to each switch. Each router is connected to 2 other routers using a /30 subnet from the 10.0 address range. Each router is also connected to a /24 subnet from the 192.168 address range, and the computers are sitting on this 192.168 range. So we can see we have computers A, B, C, and D, each with an IP address from its corresponding 192.168/24 address range. Start by inspecting the routing table on R1. If we look at R1, we see that, if we look at the routing table on R1, we see the 10.0.0.0/30 subnet, which connects it to R2, the 10.0.0.4/30 subnet, connecting it to R4. We also see the 192.168.20.1 subnet, and that is the subnet on which computer A is sitting. Looking at this routing table, does it make sense? Like, would computer A be able to ping computer B, C, or D? Well, let's confirm. Open a command prompt on computer A and try to ping computer B, which is 192.168.10.2. We can see there. Okay. We get a reply back from 192.168.20.1, which is the interface on R1 here, indicating that the destination network is not reachable. This makes sense because we don't see the network 192.168.10.0 in R1's routing table. If we were to look at R2's routing table, we see the same thing. There are 2 /30 networks from the 10.0 address range, and there is 1 /24 network from the 192.168 address range, but there are no routes to any of the other /24 address ranges. So now, if we wanted if we wanted computer A to be able to ping computers B, C, and D, if we wanted every computer to be able to ping every other computer, what would we need to do? Obviously, each router would need to have routes to the corresponding /24 address ranges. So R1 would need a route for 192.168.10.0, 192.168.40.0, and 192.168.30.0. In the same way, R2 would need a route for 192.168.20.0, 192.168.30.0, and 192.168.40.0. So what we're saying essentially is that each router will need at least 3 static routes in order for all the computers to be able to ping each other. 3 static routes, 4 routers, that's a total of 12 routes. That's not the end of the world for a small topology such as this. We can go in and manually add 12 static routes across 4 routers. But what if we had 50 routers in our network? This is not manually adding static routes is not a scalable solution as the network grows. So, are there any alternate solutions that may allow us to scale the process of managing routes in a large network? Well, this is where dynamic routing protocols come in. Let's take a look at a possible solution using a protocol called Open Shortest Path First, or OSPF. And we're going to do this by adding a couple of lines of config on each router. So let's see what these lines of config are. I'm going to first use the enable command to access privileged mode. Then we'll use conft to get into the global configuration mode. Then we will enter a command router OSPF1. We will investigate the details of these commands in a couple of lessons from now. And then we add another command, network 0.0.0.0 255.255.255.255 area 0. I'm now going to copy these commands and enter them into each router one by one. That's R1. Okay, R2, I'm pasting them into each router one by one. R3 and R4. Now let's take a look at each of these routing tables again. So I'm going to open up the routing table on each router. I will filter out the locally connected interfaces just so that we have a little more room. Okay, so we see these 4 routing tables. In order for each computer to be able to ping each other computer, what do we expect to see? What do we want to see? So if we look at the routing table on R1, we need to be able to see 192.168.10.0, 30.0, and 40.0. We've added those commands, yeah, and as we can see, automatically the routing table, new routes are getting added into the routes, into the routing tables of each of these routers. So what are we seeing here? So let's look at R1. We see a route code O, and we see the network 192.168.10.0, which is this network here. We see the next hop 10.0.0.1, which is this interface here. So essentially, we're seeing 192.168.10.0 as an OSPF route. 20.0 is a directly connected interface. 30.0, which is the network down here, that's another route, and 40.0 is another route. Sorry, 40.0 is here and 30.0 is here. So that's R1's routing table. If we look at R2, we also, with a quick look, we can see 192.168.10.0 is directly connected. 20.0 learned through OSPF, 30.0 learned through OSPF, 40.0 learned via OSPF. R3, 10.0 is learned through OSPF, 20.0 is learned through OSPF, 30.0 is learned through OSPF, 40.0 is directly connected. R4, same thing. 10.0 is learned through OSPF, 20.0 learned through OSPF, 30.0 directly connected, 40.0 learned through OSPF. Now that each router has a route to each of the 192.168/24 networks, every computer should be able to ping every other computer. Let's confirm this. Just going to close all the routing tables, start at computer C. Let's open this here. So ping 192.168.10.2. Okay, that works. Let's try 20.2. Okay, and let's try 30.2. Okay, that works. Just we can confirm from B. 2.168. Let's ping A, which is 20.2. Yep, that works. And now let's just to confirm. Yep, 40.2. So let's recap what we saw here. We started out with a, sorry, let me just close these. We started out with a network where none of the computers were able to ping any of the other computers. We added 2 lines of config on each of the routers, and after some amount of time, some routes were automatically added into the routing table of each router. Once those routes were added, each computer was able to ping every other computer. In this lesson, we just looked at 2 commands and we looked at what happened after we added those 2 commands. In the next lesson, we're going to discuss the routing table on each router in a little bit more detail, and we'll look at some of the nice advantages of a dynamic routing protocol such as OSPF.